In this section, we're going to talk about VLANs. Actually, it was so hard to understand why we use VLAN on the first day of my networking days, but after, day by day, it was easier to get it. Generally, we are making virtual local area networks on the same switch and making them to communicate. The main reason we are using VLANs is separating the broadcast traffic. As you know, on a local area network, broadcasts are not forwarded over a router. But if you use VLAN, you don't need a router to eliminate the broadcast traffic. You can use VLANs on a same switch and broadcast traffic is not forwarded between that VLANs. Each VLAN has on its broadcast traffic. VLANs are not used on plug and play, which are the dummy switches. And please keep in mind that different VLANs cannot communicate each other without a layer 3 device such as a router or firewall maybe. Let's take a look to the VLAN communication. Here we have a layer 2 switch, as you can see in here, and we have two different VLANs, and we have PC 1, 2, 3, and 4. In here, Fast Ethernet 01 and Fast Ethernet 02 can communicate each other because they are on the same VLAN. Fast Ethernet 03 and Fast Ethernet 04 also, which are PC3 and PC4, can communicate each other because they are on the same VLAN too. But Fast Ethernet 01 cannot communicate with Fast Ethernet 03 and Fast Ethernet 04 because they are on the different VLANs. If you want to establish a connection between Fast Ethernet 01 and 3 and 4 with, we need to use a layer 3 device such as a router or maybe a firewall or something like that. Let's take a look to the benefits of VLAN. VLANs provide of the following benefits. The first benefit is security. Separating systems that have sensitive data from the rest of the network decreases the chances that people will gain access to the information they are not authorized to see. The second benefit is logical grouping. When users on a VLAN move to a new physical location but continue to perform the same job function, the end station of those users do not need to be reconfigured. Similarly, if users change their job functions, they need not physically move. Changing the VLAN membership of the end station to that of the new team makes the user's end stations local to the resources of the new team. The third benefit is VLANs reduce the need of routers. VLANs reduce the need to have routers deployed on a network to contain broadcast traffic. Flooding of a packet is limited to the switch ports that belong to that VLAN. The fourth benefit of the VLAN is reducing of the network traffic. By confining the broadcast domains, end stations on a VLAN are prevented from listening to or receiving broadcasts not intended for them. Moreover, if a router is not connected between the VLANs, the end stations of a VLAN cannot communicate with the end stations of the other VLAN. Let's talk about the VLAN types now. We have 6 types of VLAN. The first type is the default VLAN. This is basically where all ports belong to by default, guys. This is technically VLAN 1 and it can't be deleted from the switch. The second thing is the second type of the VLANs are the data VLANs. This is the normal VLAN where the traffic is carried and where the client data goes through the local area network. The third is the voice VLAN. The voice VLANs are configured to carry the voice traffic. The fourth is the management VLAN. This VLAN is used on a different network for management purposes. The fifth is the native VLAN. The native VLAN is a .1Q only concept. Traffic belonging to native VLAN is not tagged. Note that by default VLAN 1 is the native VLAN on all Cisco Catalyst switches. You can designate any VLANs or as your native VLAN on your switch, and note that it needs to match on both ends of the trunk connection. The last VLAN type we are going to focus on is the reserved VLAN. There are some VLANs that are reserved internally on your switch in order to use them on other environments like FTDI, tuckering, and something like that. The specific VLANs used for these two types of networks are between 1002 and 1005. Let's take a look to the voice VLAN operation now. It is always recommended to separate data and voice traffic, and most of the times we are using a separate VLAN to carry voice traffic. Usually IP phones sit next to a computer on the same desk, guys. They require the same UTP cables as computers and also use Ethernet. This will work, but it has some disadvantages. You need to install a new cable from the switch port to the IP phone, or maybe you will lose a switch port for the IP phone. To solve this, most IP phones, including Cisco, have a 3-port switch inside of the IP phone. One port connects to the switch, one port connects to the computer, one internal port connects to the phone. This allows us to connect the IP phone and computer like you see in the screen right now. As you can see in here, we have a switch and we have an IP phone and we have a PC in here. We have just one cable coming to our IP phone, and IP phone has two different ports. One of them are local area network port. The other port is the PC port. We are terminating the cable coming from switch on the local area network port, and we are terminating the cable coming from PC on our PC port of the IP phone. And in here we have also two different VLANs. We have VLAN 10 to carry the data of the PC, and we have also VLAN 30 to carry the voice traffic coming from the IP phone to the switch. And here is the configuration. We are coming into the interface mode by typing interface and Fast Ethernet 016 for this configuration. Then to define an data VLAN, we are typing switch port access VLAN and the VLAN number. This is the access VLAN. And we are also defining a voice VLAN, as you can see, and the command is switch port voice VLAN and the VLAN number, which is 30 for this situation. Let's take to the VLAN trunking now. We have two modes of switch ports, and they are access or trunk. An access port can carry a single VLAN. However, trunk ports carry multi-VLAN information between VLANs. Each frame sets the VLAN information, and that is known as tagging 2. For example, in here we need to define the gig01 as an access port. We need to define the gig02 as access port. We need to define the gig01 and gig02 of the switch 2 also as access ports. But we need to define this guys, gig03 guys, as a trunk port, because we are gonna carry two different VLANs, which are VLAN 100 and VLAN 200 for this example. Let's go ahead with the VLAN tagging. Trunks are used to carry traffic that belongs to multiple VLANs between devices over the same link. A device can determine which VLAN the traffic belongs to by its VLAN identifier. The VLAN identifier is a tag that is encapsulated with the data. ISL and the .1Q are two types of encapsulation that are used to carry data from multiple VLANs over trunk links. ISL is a Cisco proprietary protocol for the interconnection of multiple switches and maintenance of VLAN information as traffic goes between switches. And .1Q is the IEEE standard for tagging frames on a trunk. Let's go ahead with implementing VLANs and VLAN security. We have different VLAN ranges for different purposes. The VLANs 0 and 4095 are used for system use only and they are reserved. VLAN Vlan is the default VLAN, as you know. VLANs between 2 and 1001 are used for the Ethernet VLANs. VLANs between 1002 and 1005 are used for Cisco defaults for FTDI and the token ring. And VLANs between 1025 and 4094 are the extended range VLANs and they are used for Ethernet VLANs only. Let's take a look to the VLAN configuration now. To configure a VLAN, that's pretty straightforward. On the configuration mode, we are typing VLAN and we are defining a VLAN number. In here, on the switch 1, as you can see, we are using two VLANs, VLAN 100 and VLAN 200. And by typing VLAN and the VLAN number, we are getting into the config VLAN mode. On the config VLAN mode, we can give a name to our VLANs, as you can see, which is IT in here and which is HR for VLAN 200. After opening our VLANs, after configuring them globally, then we are getting into the interface mode. For example, for interface gig01, we are defining the switch port mode as access because that's carrying just one VLAN. Then we are assigning our switch port to the related VLAN, as you can see. The same thing in here also. Let's take a look to the trunk configuration. On the gig03, we are gonna make a trunk configuration because I'm gonna carry multiple VLAN information from here, which are VLAN 100 and 200. So to define a trunk, we are configuring switch port, trunk, and we are typing our encapsulation type, which is .1Q in here. Then we are typing switch port mode, trunk this time instead of access. Lastly, we are typing the switch port trunk allowed and we are typing the VLAN numbers that we are allowing to go from that trunk. Let's take a look to the dynamic trunking protocol, DTP now. DTP is a Cisco proprietary trunking protocol which is used to automatically negotiate trunks between Cisco switches. Dynamic Trunking Protocol DTP can be used to negotiate and form trunk connection between Cisco switches dynamically. Dynamic Trunking Protocol can operate in different trunking modes as shown in the graphic. If you want to create a trunk link between two switches, you should use, for example, trunk and trunk on both ends. You can use trunk and auto. You can use trunk and desirable. You can use auto and trunk, auto and desirable, and also we can use desirable with the trunk, auto and the desirable also. As you can see in here, one side is configured as switch port mode dynamic desirable, and the other side is auto, and as I showed you on the previous slide, desirable and auto is forming a trunk link, but in here we are defining auto on both ends, but we cannot perform a trunk link. To verify our trunk ports, we are using show interfaces trunk commands, and we can see the trunk ports which are making an actual trunking at that moment. Another verifying command is show interfaces and interface name and the switch port. We can see the administrative or the operational mode if they are trunk or not. Let's take a look to the common VLAN attack types. A switch interface which is connected to an end device, a computer maybe guys, or a printer, are normally in access mode, and that end device will have to access to its own VLAN. Traffic from the other VLANs are not forwarded via that interface, as you know. Consider a situation where an attacker is connected to a switch interface which is configured with either dynamic desirable, dynamic auto, or trunk modes. If the attacker can generate DTP messages from his computer, a trunk link can be formed between his computer and the switch. Another method of switch spoofing is by connecting a rogue switch to an interface configured with dynamic desirable, dynamic auto, or trunk modes. Let's take a look to the double tagging attack lastly. Double tagging VLAN hopping attack takes advantage .1Q and .1Q tagging and tag removal process of many types of switches. Many switches remove only the .1Q tag. In double tagging attack, an attacker changes the original frame to add two VLAN tags, an outer tag which is of his own VLAN and an inner hidden tag of the victim's VLAN. Here the attacker's PC must belong to the native VLAN of the trunk link. When double tagged frame reaches the switch 1 in this example, the switch can only see the outer VLAN of the VLAN that the interface really belongs to. The switch 1 will now remove the outer VLAN tag and will forward to all the ports belong to native VLAN, and in this example that is VLAN 1. One copy of that frame is forwarded to the trunk link to reach the next switch, which is switch 2. When the frame reaches the switch 2, it will open the frame to see the second tag. Switch 2 will now assume that frame belongs to VLAN 100 and it is forwarded to VLAN 100.